Are we live and in person?
Yes.
Good morning, class. It's Happy Blues Day. This is Super B Productions. Today we're going to try to talk about three kinds of chemical reactions. There are 5 altogether, but we're just going to have 3 for today. At the end of the day, into this little video, you will go through those 3 worksheets and label the chemical reactions: synthesis, decomposition, and combustion. And the reactions that we're going to work with today are right here. You can pause the video and write all of these down. And I've numbered them. Okay? The first kind of reaction that we're going to talk about is synthesis. Synthesis. Nice and easy. 1 plus 1 equals something new. That is synthesis. Synthesis means to make something. So if you have 1 plus 1 equals something new, you got synthesis. That's as simple as it gets. If you look back on your notes there, the first 2 equations are synthesis because you have 1 plus 1 equals something new. Hydrogen plus oxygen equals water. Water is something new. You have iron plus oxygen equals iron 2 oxide. You got something new. Those are both synthesis reactions. We'll go back later and balance and name. That is synthesis. That is 1, the first kind. The second kind of reaction we're going to talk about is decomposition. Decomposition, as the word says, decompose, break down. You have one thing that breaks down into 1 plus 1. It's the direct opposite. It's the reverse reaction of the first one. Synthesis is decomposition in reverse and vice versa. Decomposition, you have one thing that breaks down into 1 plus 1. If you look at your reactions that you've already written down, 3 and 4 are decomposition. You have one thing that breaks down into 1 plus 1. You have water that breaks down to hydrogen plus oxygen. This decomposition reaction has a special name. It's called electrolysis, which I'll write for you, being the super teacher that I am. Electrolysis. The decomposition of water is called electrolysis. Those of you who are still awake and still aware know that we've already talked about this earlier in the year. So you have water, which decomposes into hydrogen gas and oxygen gas. You have mercury 2 oxide, which decomposes into mercury and oxygen gas. These are both decomposition reactions. One thing breaks down into 1 plus 1, the reverse of synthesis. Cool. Thank you very much. And finally, for today, the reaction that every chemistry student wants to know about. Super B, will we blow something up? Well, whenever I do return, we will blow something up besides your brains. Combustion. Whoop, whoop, combustion. You have to have a carbon-hydrogen fuel plus oxygen and, very important, a spark, a flame, a fire. If you keep that propane, methane, ethane, butane, heptane, etc., under controlled circumstances, it'll stay there until the end of time. But if you have oxygen and a spark, boom, you got combustion. That's why when it says flammable, you better be careful because it could lead to a big explosion. It'll stay the same for all eternity, but if you put a spark in oxygen, it may send you to eternity. Look at your reactions. Number 5 and number 6 are obviously combustion. Whenever you have a carbon, hydrogen fuel plus oxygen, you always get carbon dioxide and water. Every time. Carbon, hydrogen fuel plus oxygen gives you carbon dioxide and water. So in the first one, you have methane plus oxygen equals carbon dioxide and water. Well, guess what? When you get propane plus oxygen, you still get carbon dioxide plus water. Whoop, whoop. That is called a combustion reaction. But right in here, in both of those, you got to have a flame. And you usually write it like that little delta there. There's some kind of spark. There's some kind of fire. There's some kind of flame to make the combustion happen. Thank you very much. Now, for those of you who still are there, let's go back and balance these reactions. We've already said what the word names are for them. So let's look at this one right here. You have to get 2 oxygens on this side over here, so you put a 2 here. So now you have 2 oxygens, but now you have 4 hydrogens. So all you have to do is put a 2 there, and it's balanced. You got 4 oxygens and 4 hydrogens, 2 oxygens, and on this side you also have 4 hydrogens and 2 oxygens. On this one right here, you got 2 irons, you got 1 iron, you got 3 oxygens, you got 2 oxygens. So in order to get these oxygens balanced, you're going to have to put a 2 here, which gives you 6 oxygens. So on this side, you also need 6. So you put a 3 there. So that gives you your 6 oxygens and 6 oxygens. But you also got to have 4 irons. So you simply put a 4 right there, and it is balanced. 4 irons, 6 oxygens. 4 irons, 6 oxygens. By the way, hats off to my lovely daughter who's videoing this, who took time out of her busy kindergarten teaching day to come help her old man get better. And she is just a total delight. She also has on blue today, by the way. All right, let's balance this one. Water plus H2 plus O2. Well, guess what? It's just the reverse of the other one, so it's going to be the same doggone thing. 2 there and 2 there, and you are done. You are easily done. All right, let's balance this one. You got 2 oxygens over here and 1 here, so you can clearly see you need to put a 2 right there. So that gives you 2 oxygens, but it also gives you 2 mercuries. So you'll have to put a 2 there, and you're done. Easy. This balancing stuff is so easy. What's all the whining about? All right, let's go down to this last one. And these are always the more difficult, the combustions, just tell you that right out front. So let us start with the carbons. This carbon's good, that's carbon's good. Well, hydrogen's not so good. We got a 4 and a 2. So we'll put a 2 right there, which gives us 4 hydrogens and 4 hydrogens. Now let's count up the oxygens. We got 2, and 2 is 4. So we put a 2 right there, and that gives us 4 oxygens, 4 hydrogens, 1 carbon. 1 carbon, 4 oxygens, 4 hydrogens, balanced. This is so easy. All right. Then finally, let's balance this one. We'll start with the carbons. We got 3 there. So let's put a 3 here. So now we have 3 carbons and 3 carbons. Now we got 8 hydrogens. So we put a 4 there. And what do we have? We got 8 hydrogens. We got 8 hydrogens. We got 3 carbons. We got 3 carbons. Well, now we got to deal with oxygen. That's all. We got to have it to breathe, so let's deal with it. So we got 3 times 2 is 6, plus 4 is 10. Well, how can you make 2 10? Even the kindergarten kids could tell you. You put a 5 for the coefficient, and now you have 10. So now it's balanced. 3 carbons, 8 hydrogens, 10 oxygens. 3 carbons, 8 hydrogens, and 3 times 2 is 6 plus 4 is 10 oxygens. Balance, good, done. Y'all get your work done. I'll be back to check on you. Have a good day. Boom.